Alright, hey there everybody, welcome back to another video. In this video we're going to go over arrays, dictionaries, and structs in Cadence to help build up our Cadence knowledge and our Cadence syntax. So in this contract what we're going to do is we're going to just define some state and logic like we've seen previously to try and just learn the syntax around arrays, dictionaries, and structs. So let's do that. Let's define a array in Cadence, and so we can do that by saying public var all names. So what we're going to do is we're going to store an array of a bunch of names, Jacob, Alice, Bob, it could be whatever, and people are going to be able to register names and store them in this array. So how you remember what I said in the last video, in order to declare a variable, you'd say public or an access modifier, var or let. In this case it's going to be var because we're changing the array, and then the name of the variable. And then the type is always after a colon. And so how you specify an array of a certain type is you do an array, like you do the brackets and then the type of the array, the type of the elements inside those brackets. So in Cadence you can't really have arrays of multiple types unless you do something special, which is called any struct, and then you could put anything in there. But usually you would have to put a string, and so in this case we couldn't put like integers in here. So you have to make sure the type is set. And so we can initialize this array by just saying in the init function, remember, just saying it equals the empty array. And what we can do is we can add a function here called public function add name, and we'll take in a name parameter, and inside this function we will say self.allNames, and then we're going to append. So append is how you add a new element to an array. It just adds it to the end, and we'll add that name to the end of the array. So if you're confused about this function syntax or how to declare a variable, make sure to go back to the previous video because we explain it there. Alright, so we can deploy this contract, and you'll see it gets deployed. I've already done this multiple times, just practicing. And because we're going to be changing the state of the blockchain, remember, we're going to be inside of a transaction. We're changing the state of the blockchain by adding to that array. And so in this transaction, we could actually, add something to that array. So let's actually, you see, I already have a parameter in here that's passing a name that we can type over here. And we're just going to say ADS, which is the contract we deployed, dot add name. And look, I just pressed tab and it already did it for us. So this is the argument or the parameter label, right? Because that's what we called it right here, name. And then it happens to be that we also called this name, and so that's why this is here. So let's actually add Jacob to this, and it doesn't matter who signs it, so we'll just send it. Okay, so it submitted because it says ready, and then let's go back to our script over here, and let's actually try and read that array to see if there's any changes. So we can say ads dot all names, and that's the name of our state here, the state array, and we're going to return it. So in order to return it, we're going to return an array of strings. And we're just going to add a simple return here. So let's actually clear this and execute this script. Remember, we're just viewing the blockchain, and you can see, boom, Jacob is there. So we've done it. All right, cool. So there's other things you can do on arrays. We could log self.allnames.length. That's how you get the length of an array. Another thing you can do is .concat. So you could do something like self.allnames .concat name, but concat is different from append in that append changes or actually modifies the array, whereas concat just makes a new one. So you would have to say something. This wouldn't actually modify all names. It would just add something to the end of it, and then you could store that in some other variable or something. So those are two things to take note of. Another thing is that you can insert elements at specific indices. So for example, if we had an array that looked like this, and we'll add Alice. If you had an array like this, right, so we will say public let array equals this, and we said array.insert, and you used the argument label at, and let's say 1. And then you put another name here, so let's say Samantha, right? Then what this would actually do is array is now equal to this same array here, except it inserted Samantha at index 1. So it would put Samantha right here, and it shifts everything else down. So if you want to insert elements of specific indices, you can definitely do that. Okay, so I will delete this for now just so that it looks much cleaner. All right, so now let's get into dictionaries. So let's add a dictionary called public var, and what we're going to do is we're going to map the name of a person to their lucky number. So we'll say lucky numbers. So we're going to do a string, and this is going to map to an integer. So how you declare a dictionary, and dictionaries are something that has keys and values, so you map a key to a value. And in this case, we're going to map a name, which is a string, and we're going to map that to a value of a lucky number for that person. So again, in dictionaries, you have to specify the type of the key and also for the values. So let's add a function here. A function add lucky number, and we're going to take in a name, which is a string, and a lucky number, which is an int. And we will open this up and say self.luckyNumbers at that name equals the lucky number. And what we can actually do also is we can add a check just for fun to make sure that that name already exists in all names. So we can say in Cadence there's something called a precondition, and a precondition on a function is basically a check. And if you've done Solidity, it's almost like require. Or like a function modifier, but you can add a precondition, and this just says that make sure whatever is in here is true before we execute the rest of this function. So we can actually say, so we want to make sure that that self.allNames.contains the name. So you can use .contains to see if something exists in an array, and if it doesn't, then we'll say an error. This name is not in all names. All right, and so it's also complaining that we have to initialize our lucky numbers. So let's do that, and you initialize it just to empty brackets here. Okay, cool. So let's actually redeploy this contract, and it's redeployed. I should probably clear this, and let's do a new transaction here. So we're going to do a new transaction, and we're just going to add lucky number. And let's just copy and paste this syntax here just so that it's much easier. Okay, so we'll take in a name, and we'll also take in a lucky number, which is an int. And we're going to say add, or what is it? I think is it lucky number? Oh, add lucky number. Okay, so we're going to say ads.add lucky number. And we're going to say the name is the name and the lucky number is lucky number. And it's going to complain. We just have to refresh again because the playground is sometimes buggy. Okay. So we're going to say that, let's actually try to do this, right? So let's say that at Jacob, we want to add the lucky number 13. But I want you to think about what's going to happen when we do this. Because remember, we added a check to make sure it's already in the array. And Jacob isn't currently in the array because of the fact that we redeployed the contract, so all the state got reset. So if we submit this, look, precondition failed. This name is not in all names. And that's because that when we redeployed the contract just now, it reset all the state, so Jacob was no longer in the array. So we should go back to this transaction and first add Jacob to our array, so we can send, and it executes. And then now when we go to add lucky number and we add Jacob 13, it will actually work now. And so you'll see that it goes through and we're all good. So now in our script, what we can do is we can add another script here. So to read lucky numbers. And let's just copy this script just for the syntax. And we're going to return a dictionary that maps a string to an int. And let's return ads.luckyNumbers, right? And if we execute this, then it says it's a dictionary, so it's a bunch of like weird like JSON format. But basically it says Jacob maps to a value of 13. So boom, we did it. All right. So let's go back and let's also just I'm going to talk about some functions that you can add or some things that you can do with dictionaries. So with dictionaries, I'll put this here. You can do self.luckynumbers.keys. And what this does is this returns, so this returns an array of all the keys. You can also do self.luckynumbers dot values, and this returns an array of all the values. And you can also do stuff like you can also remove elements. So what you can also do is self.LuckyNumbers. If we wanted to remove an element, dot remove, and the key we would want to remove is, let's say we wanted to remove a name. So this would just remove a mapping from that key to whatever value that key maps to. Okay, so this is just some interesting stuff we can do that I just wanted to make clear. Okay, so I apologize for the weird edit in the middle. I know this is going to look weird, but I was just watching over the recording and realized I completely forgot how to mention how to actually put values in your arrays and dictionaries when you're initializing them, right? So it's not always going to start from 0. You can put stuff in them, and I want to show you that syntax. So let me just do that really quick, and then we'll get back to the rest of the video. So if I want to do an array that was holding an array of strings, you could do something like this, where you have hello, and then the next element could be world. So I just wanted to kind of show you what that looks like. And then another thing is, if we were doing like the dictionary syntax, you could do a self.dictionary or test.dictionary, and then the syntax for this is, if we're mapping ints to strings, you can do something like 3 maps to 3, and you can do, I don't know, 4 maps to 4. So I just wanted to show you what that syntax is, because you might, if you're testing, you might want to do stuff like this. So this is how you would initialize it. And one more quick thing. I'm just going to do something really quick. So pubvar stuff, and this has type any struct. I wanted to make one point about the type any struct. Any struct basically means the type can be anything. So if we do self.stuff, you can actually see that we can put 3, we can put hello, we can put a fixed number, and it works totally fine. So I also wanted to make that point about any struct. All right. Back to the rest of the video. I apologize for the weird edit in the middle. Now we're going to talk about structs. So the last thing I wanted to do in this video is talk about structs. So as in any other programming language, structs are really just for containers of information. So let's say that we wanted to, instead of just mapping lucky numbers from a name to an integer, let's map from a name to things about that person, right? So we can call this identities. And we'll map this to a identity. So we haven't defined that yet, of course. So let's actually define a public struct named identity. This is actually no race things here. And in this identity, we'll have a lucky number. So lucky number is going to be an int. But we're also going to have, let's say, a favorite fruit. And this is going to be a string. So structs are very similar to contracts in that you have to also define an init function for an initial state. And so in this case, we're going to take in a lucky, when we initialize this struct, we're going to take in a lucky number, and this is going to be an int. And we're also going to take in a favorite fruit. Now you'll notice that I'm including, underscores here, and I do that because I just tend to do that in Cadence. I always include underscores in my init function. And so that's why I'm doing it here. So then we have to initialize our things. So it equals lucky number and self.favorite fruit equals favorite fruit. And remember, self always refers to the level just above. So this is where we are now. Okay, cool. So identities, so it's not liking this. This is because this is now identities. And we'll also change this function to, instead of adding a lucky number, we're going to say add an identity. And so we're going to map a string to, let's take in a lucky number, and let's also take in a favorite fruit, which is going to be a string. And we're going to still make sure that it's contained in the array, but what we're going to do is we're going to say identity, and the name is going to be a name. The identity takes in 2 things, right? The identity takes in a lucky number and a favorite fruit. So it's going to take in a lucky number, which is the lucky number, and a favorite fruit, which is the favorite fruit parameter. So this parameter right here maps to this one, as it's showing. This one maps to this one. And the reason we're putting these here is because when you make a new struct, it calls the init function of that struct. So we have to still use the argument labels that are used in this init function. Okay, and this is also called identities. So now we can actually redeploy our contract here. And now, we've mapped a string of name to an identity struct. So let's actually go to our transaction. Let's add a new transaction, and let's call this add identity. Let's copy and paste this code here. And what we're going to do is we're going to also now add a new parameter named favorite fruit, and this is going to be a string. And then inside here, we're going to say add well, let's actually refresh the page so that it gives us this like auto completion. So add identity, name, lucky number, and favorite fruit. And this is supposed to be a string. So this is a string. So let's pass in, oh, remember, we have to still add our name or else it's going to complain because we just redeployed the contract again, so the state got reset. So we have to add that name or else it's going to complain in that precondition. So we'll add Jacob here. And then inside our identity, we're going to do Jacob, the lucky number is 13, and the favorite fruit is going to be apples. That's a fruit, right? I hope so. Oh my god. Okay, so we send this. And we add a new identity, so it's done. And we can now add a new script, and we're going to call this read identities. And let's copy and paste this code. And we're going to return instead of a string to an int, what we're actually going to return is an identity. Now the problem is that this script doesn't know what identity is, right? Because in theory, like, when we're on the playground, like, it seems like it's very easy to tell what identity is. But think about an actual script. A contract just lives somewhere on the blockchain, and scripts are called by people that want to interact with that. So the scripts don't know what identity is. So you have to specify that the type is ads.identity. And then here we're just going to return ads.identities. And when we execute this script, you'll see it returns a Jacob key. That's the key. And the value for that mapping is a struct that has a value of fields that is a lucky number, which is 13, and a favorite fruit, which is apple. So it's a lot of JSON stuff, but that's essentially what it's doing. Now, one thing I also wanted to note about structs is that well, two things actually. So for a struct, it's always pub. So I know I was talking before about how this will talk about access modifiers can be changed, but for contracts, contracts are always pub, structs are always pub, and resources are also always pub. Which we'll talk about later. There's no real reasoning for that, but just when you're doing structs, you always put public. So just make sure that you do that. Okay. And the last thing I also wanted to say is that structs can actually have functions inside of them. So if we had a struct, we can actually, if we wanted to, we could actually run a function on this identity. So let's do public function change favorite fruit to a new fruit. This is going to be a string. And we'll open this function, and we're going to say self.favoriteFruit equals the new fruit. This will actually change, and of course it's complaining because see let, so let we need to make a var because we're changing it. And we can actually redeploy this contract. And let's actually try and call this function on our identity. So what we can do is, we have to add our Jacob again because I redeployed the contract. I notice now it's probably annoying to have to do this, but we have to add Jacob to the array, and then now we can add a new identity. So the lucky number is 13, and the favorite fruit we'll say is apples, and we'll send this transaction. So if we were to go to our script and read our script, you'll see that returns our identity. But let's say that we actually want to change that and we want to call that function right inside this identity right here. Let's actually in a new transaction called change fruit, we're going to make a new transaction, and this is going to take in just a name and a favorite fruit. And I'll show you why in a second. So what we're going to do is log ads.identities at name, right? And then what we're going to do is, so this is going to log the identity. Then what we're going to do is say ads.identities or ads.identities at name, and we're going to call, so dot change fruit. Is that what it's called? Change favorite fruit. So change favorite fruit, and we're going to pass in the new fruit is our favorite fruit. That's coming from this parameter, and the playground is buggy. Change. Oh, okay, so I'll explain this in a second as well. So the reason it's giving us this error is because of something I said in the previous video. So in the previous video, we were talking about optionals, right? An optional is a type that has a question mark after it, and an optional can either mean nil or the value we put there. And I said this would come up especially with dictionaries, and that's the case here. So what usually happens with dictionaries is that if you try to access a value of a dictionary, so in this case, ADS.identities@name is an identity struct because that's the value. If we look back here, that's the value here. When you are just trying to read it, so in this case, like we're just logging it, then it's totally fine to just log it, and we don't have to unwrap anything. The optional is fine. However, when we call things on a value that's coming out of a dictionary, you have to unwrap it using the force unwrap operator I showed in the previous video. And the reason for this is because of the fact that dictionaries, let's say that we had a dictionary, right? And we were trying to get, let's say we, trying to access a value that has a key of John, right? And let's say that we never put John into the dictionary as a key value mapping. What's going to happen is that ADS.identities@John is going to return nil. Well, it's going to return an optional, but that optional can be nil. And so the problem is that we risk that we could call a function on a nil, which isn't possible. And so the reason why we have to put an unwrap here is because it's going to say, okay, go try and get ADS.identities@name, return an optional, which is either nil or an identity, and then we're going to unwrap it using this. And remember, the unwrap says, okay, if that key value mapping exists, then get me the actual type, which in this case is going to be ADS.identity with no question mark, right? Or if that didn't exist, it's going to return an optional, and then when we go to unwrap it, it's going to actually return nil, right? But the thing is that the force unwrap operator just panics. It just aborts the program if it's nil. So in this case, if ADS.identities@name isn't a mapping or it's nil, then it's just going to abort the program. But the hope is that something will have been there, and the force unwrap operator will actually return an identity struct that we could call change favorite fruit on. And so with that said, we can actually go in and change. And so let's change our favorite fruit from apples to bananas. And if we send this, you'll see that it changed from apples. So I'll actually just move my camera for a sec. Ooh, I'm floating. From apples to bananas. And so you can see that change happened. So I know this video was sort of long, but thank you so much for listening in. And I will catch you all in the next one.